Hello friends, myself Chintan Varia.
And this is Syed Waleed bin Nazar.
We both are working on our final term project of EE278 under the guidance of Professor Cheng Chu. Our project is feature extraction.
So to start off, I would like to discuss the feature detection. Basically, when we see a picture, we distinguish between the objects based on their unique features. These points of interest demonstrate particular characteristics which help us in recognizing objects. For example, when we see a picture of another person, we recognize him or her using eyebrows, nose, lips, ears, etc. So basically, feature detection and feature extraction and matching are often combined to solve computer vision problems such as object detection and recognition, content based image retrieval, face detection, and recognition. We started our project implementation through Matlab, and for this we used image of Bollywood actress Aishwarya Rai. And now moving on to our code, you can see that in first line we are basically trying to load the image, and then the second line we are converting it from RGB to gray, and then in the third line we are converting it to a 64 by 64 image so that it could be used for further processing. After that, we are using a famous feature detection algorithm, Harris features, to detect the edges, and then we are plotting the image using the strongest feature points. Now we will compile our code to see the results. As you can see, the green stars which denote the strongest feature points located by the algorithm in the image.
Now after getting the result from Matlab, we will move towards the C code implementation. So for the C code we need the input image matrix as an input to the C code. So for that we have already generated the C code through this IM resize 64 by 64 cross matrix that we have already generated, that you can easily get through your workspace. Here that was the variable j, so just double clicking on j you will get this pixel value of 64 by 64. This 64 by 64 pixel data matrix can be used as an input to the C code. So now we will do our C code implementation. For that you can use any C compiler. I have used the Quartus 2, and in that I have used the Eclipse. So for that you can just simply open the Quartus 2. In tools you can find down here Neos 2 software build tools for Eclipse. So just simply click on it. It will just take a few seconds to open. Okay, so here is the first window. You can select your workspace. So it is the default folder till here, and I have created another term project folder in which I am going to include all my files so that I can store that for the further use. So just include the name and okay. Okay, so this is the main window of Eclipse. So first of all we are using the C code, so we have to shift our simulator from Neos 2 to the C++. It is here in the right side corner of the window. Just simply click on it, C or C++ perspective. Now it's my C and C++ perspective window. Now we have to create one new project in which I can include my all the files and I can compile and simulate it. So for that just go to files, new. I am working on C, so C project. You have to give any name. I am just right now giving any random XYZ name. I am using the tool chains min GW GCC, next, and debug and release, that's the standard, and finish. Okay, so now you can see over here that the XYZ folder is created and it has all the standard C compiler files. Okay, but I have already created my own project, so I'll just simply delete this one right now, and just this TP is my already generated project. I'll right click it on it and open project. So now you can see I can use all the files. So this 1.c is my C code file. I'll open it, and here you can see that this is my code. So this is now the matrix values that we have generated through Matlab, and I have directly used that values as an input to my C code. These all are my black and white image pixel data values. Okay, so now after writing my whole code, I'll just simply compile my entire project. For that, just right click on your project folder, build your project. It's saying building project. Okay, so my build is complete. So now I have to run my project. So for that I have already the shortcut over here, run as C or C++ application. Okay, so now over down here in the console window you can see the simulation is done, and it has generated one output file which has all the data coordinates values which are the feature points of my C code, of my image, which is found from this entire matrix. So I will just show you where it is. So it is in the default folder, so it's in C Altera. The folder was Tom project, my C project was TP. So over here this C feature point.txt, these are all the feature points that I have got from the C code. But as you have already seen that from Matlab we have plotted them on the image, so you can easily distinguish over there like this. It's the images here, and these are the edges there. Just for example, the eyes, the face edge, the hair, wherever there is a change, there is a edge or corner, it is notified, so you can easily get, okay, this is the feature point. But from this text file, all this coordinate file, you can't get the exact idea, okay, these are right or wrong. So now we have used these data points as an input to our Matlab code. We have wrote down another Matlab code for that, and we have overlapped already generated feature point output file. On this we will again plot that all the coordinates, and we will show you that they are also the right. Okay, so for that I will simply copy my this file from here and will put it back in the default folder of my Matlab, which is in documents and Matlab. Okay, so here is the file that you can see. It was already there, it has just I have just replaced it. Okay, so now I am using this file as an input to my another Matlab code, and will show you the feature points of Matlab and feature points of C code of the same image. So for that I will just simply go to the Matlab. Okay, in Matlab here in this another window, C coordinate, I already wrote down the code. Here you can see that this is the file name C feature point.txt. This is the file which is recalled from the default folder of Matlab and will used as an input to this entire file. Okay, so now I'll just simply run the code. Okay, so now I have got the final result. The red cross marks are the feature points which I have got from the Matlab implementation, and the circled one, the green one, which are, you can see that, which are very near to the red one, which are the feature points from the C code. So this is giving us the very nice result, that the feature points that we are getting from the Matlab and feature points that we are getting from the C code, both are very similar and very near to each other. Okay, so till now we have implemented our feature extraction project in C and Matlab, and we have got the similar results that we have already shown. So now we are going to implement our feature extraction algorithm in the Verilog. So for that we have used the quarters 2. So first of all we have to create one project in quarters 2. For that, this is the main window of the quarters 2. So now create a new project, and next. Okay, so now here you can give any folder or directory that you want to create, and in which you can store all your files. So I'm just writing demo. Then so the new demo folder will be created, and in which all my project files, Verilog files, will be stored. I'm writing the project name as ABC, and next. So it is asking me to create a folder, as it does not exist right now. So yes, I want to create it. Now if you already have any Verilog files that you want to include in your project, so you can directly click here and select according from the location, and you can open it. And once you are done, the add button will be highlighted, and you can simply add. So all the Verilog file which you have selected will be shown here, and it will be added in your folder, in your project. So now I don't want to add any right now, so I will simply go to the next. Okay, so now this is the window to select my device. So I am using the Cyclone 2, and I need to select my processor. So for that, the pin count is 484, speed is grade 7, and this one EP2C20F484C7, this is my device. So I will select it and just simply next. Okay, I'm going to show my output in the waveform of Altera model sim. So I will select the Altera, and I am doing all this in Verilog. So Verilog, next. And this is the final window. It shows you all the details, and as soon as you will enter the finish, it will create a new project here, over here in the project navigator. As I already have created one project in which I was working, so I'll simply open that and will show you all the compilation and the result files from there. So I'm cancelling this, and okay, something is processing, so I have to wait. Okay, so now I'll simply open my already created project. So it's open in this, the final two, and the project files comes under the QIP. So okay, sorry, it comes under the QPF, so it's feature.qpf. This is my project. So open. Okay, so here you can see that it is all added. This is Cyclone 2, my device, and all that stuff. It is there. Here are the two files. abc.v is my Verilog file, and def.v is my test bench. So here the test bench is the input of the pixel data matrix that I have got from the Matlab. I have used that pixel values as an input to my Verilog code, and that I have added in this my test bench. So once you have to include a test bench, you have to assign that file as an test bench file. So for that you have to go to assignments, settings, that I want to declare DEF as an test bench. I want to use the data from DEF as an input to the ABC. Okay, so here you can see Okay, in the simulation you can see that over here it is the compilation test bench. You have to simply select the file over here. DEF is already selected and you have to click OK. Okay, so now DEF is declared as my test bench and I have to assign my main Verilog file as top level entity. So just right click on it and set as top level entity. Okay, so everything is set and now I'll compile my uh, Verilog files. So start compilation. So over here in the task window you can see that it has started the compilation and all the messages regarding that you can see over here in this console window, message window. It takes around 40 to 50 seconds. Over here you can see that it's 20% done. Okay, so now it is showing that full compilation was successful and I'll simply click OK. So now I'll show you that as it is working, I have to show you that what the feature points that I am getting. So for that I am using the model sim Altera to show the waveform, and for that you have to simply click on RTL simulation over there and okay, I'll just click it. Okay, so now it is opening model sim Altera. So now you can see that it is open model sim Altera and here is the waveform file. Just simply open it, fit to screen. Okay, so now these x and y are my x and y coordinates of the feature point that I have got from my Verilog code. I will just put them to the radix to decimal so that you can get an idea of what the value that I am getting. Okay, so now they are in decimals and I will simply zoom it. Okay, so now all these x and y respective coordinates are the points of my image which shows some feature, the change in the image. And as we have already shown that we from the C code we have also got an matrix which was containing the coordinates of feature points, and we have from Verilog we have also got the same kind of coordinates, and we have compared both the data from Verilog and C, and both are very similar. And okay, so now till now we have seen our feature extraction project implementation in Matlab, C and Verilog, and from all these modes we have find the similar results and we have shown that they are almost same. Now after all this we are finally showing a one last step. In this we are going to interface our D1 development board with the from the VGA port with the LCD screen. Okay, so for that we have to first program our D1 board with the interface program. So for that I will open my quarters 2. I will connect my D1 board with the USB cable. As you can see, it is powered on and the lights are all flashing and it is right now in the run mode. So for that now we will go to our quarters 2 window. To program, just go to tools and programmer. We have to install our interfacing program. So first of all I'll delete my old one. delete. I will detect my hardware. It is EP2C20. I'll select it and OK. Okay, so you can see that my device D1 board has been detected through my USB port. Now I have to add my program file. So just will click on add file and find the path where I have stored that files. So this is the SOF software file. I will open it. I will remove this one. So this is my program, that file that I need to burn in my D1 board, and start. Okay, so over here you can see that the Altera D1 default window screen is showing in the LCD screen, and in the quarters 2 it is showing the 100% successful. Okay, so now I need to load my image into the memory of D1 board. So for that I first need to convert my final image to the grayscale image raw data, which is the supported format by my memory in the D1 board. So for that I will open my image converter. I will open my bitmap file. This is my final Matlab and C feature point combined image file, which shows both the feature points. I will open it and will convert it to the raw data. Over here you can see that it is processing. Okay, so convert is successful and it is okay. So now I have got my black and white grayscale raw data conversion. Dat file is generated. I need to burn it into D1 board. So for that I will go to D1 board control panel. I need to start communication. So I will open USB port. So it has been detected. You can see over there. I am going to burn my raw data into static RAM memory. So I will go to the SRAM tab. I need to burn the entire file. So select file length. So it will start from beginning till the end, and I will need to write that file to the memory. So write a file to SRAM. Now I will select the path, and this is the raw data gray.dat. This file I need to burn, so I'll just select it and open. So now over here you can see that it is processing. It is burning the file to my D1 board SRAM. And the processing is complete. Now I'll go to tools. I have to select the host USB port, and in that I will select asynchronous one. I will configure it. Now I will this is my VGA port screen. So over here right now it is showing the default image, which you can also see on the LCD screen. So as soon as I am clicking on the default image, I am removing my default image. You can see over that I am getting the final image, which has the plots of C code and the Matlab. And through this cursor I can show you. Okay, so over here on the intersection you can see there is one circle and also one star, which shows the feature points. Okay friends, with this we are concluding our project demo, and this was really a very good experience for both of us. We are really very much grateful and thankful to Professor Cheng Chu. It was really a great learning lessons that we have get from this class. It is really helpful to us. Thank you so much.
Okay guys, I hope you will find this video very useful, and it will help you in learning more about how to operate the board and do image processing. Enjoy. Bye.